So now we are launching into chapter 2 and we have some new topics. We're going to be looking at equations and inequalities in one variable. So we want to be able to first identify what is a linear equation. I want to be able to use the addition property of equality, and then I want to be able to simplify using that property. So the first thing is an equation is a statement where two algebraic expressions are equal. So an expression does not have an equal sign, but an equation does. So when I'm looking at all these examples on the screen, there is an equal sign, so they are equations. To know if it's linear versus nonlinear, in a linear equation, the highest exponent is 1, and there's always a variable. So if we look at what these all have in common, 4x, 2x, and x. All of those exponents are 1, and there's a variable. At the bottom, I have an exponent of 2, so it's nonlinear. An exponent of 3, nonlinear. 1 over x would be a negative exponent, so that's not going to count, even though it has an exponent of 1. And then I have an absolute value. I can't have an absolute value in a linear equation. So the solution of an equation is the number that makes it true when I replace the variable. An equation is solved by finding its solution set. Equations with the same solution set, meaning the same answer, are called equivalent equations. So in this property, the addition property of equality, if I'm trying to isolate a variable, which means get it alone, what it says is I can take the inverse operation of subtraction. So what is the opposite of subtraction? It's addition. And I can add 12 to both sides to get x alone. So the addition property of equality is this step with the blue. It's when I'm adding the same value to both sides of the equal sign, which then results in negative 12 plus 12 canceling out, and I have x equals 9. I want to check my work. I substitute 9 minus 12, and it's negative 3. So that is a solution. It is true. The line of final check doesn't give a solution. It's just confirming what you've done and that you're checking your work. In the lab, you have limited attempts, so take the extra 2 or 3 minutes just to check your work and make sure you didn't make a mistake. Here, I have m minus 4.1. I need to get m by itself. So the inverse operation of minus 4.1 is plus 4.1. So I'm going to add 4.1 to both sides to get my final answer, and that should be m, not x. Then I'm going to check my work, and I know I got the right answer. So just taking that extra moment or two is going to make sure we don't make a mistake in our arithmetic. So in section 1.4, we said subtraction was the same as plus negative. So the same can be done when we're actually solving an equation. So here's my equation, x plus 16. I can do the inverse operation of addition, which is 16, and I can subtract 16 from both sides. So all we're doing is opposites. If I'm adding 16 to x and I want to get rid of it, I'm going to subtract it from both sides. And then I'm going to check my work. Why does this fall under the addition property of equality? Because technically I could say I added negative 16 to both sides. That's probably not what we would say. We would probably say we subtracted and we did the subtraction property of equality. But to be technical, it can be addition of a negative. Now I have z's on both sides of my equation. So I want to get all of my z's grouped on the same side. I'm going to use inverse operations. Now, it is much easier to bring 11 over to the right so that I can have all my z's on the right, because then I'm not dealing with negative values. So I'm going to do the inverse operation. It's a positive 11, so I'm going to subtract 11 from both sides. When I do that, 12 minus 11 is 1, and then the negative 9 is alone. We can check our work by plugging negative 9 in for z, and we see that it is in fact true, so negative 9 is a solution. Now we have some fractions, everyone's favorite topic. It is easier to move 7/2 over than to move 9/2. So since 7/2 is positive, I'm going to subtract it from both sides. 9 minus 7 is 2. So I have 2 over 2p. 2 over 2 is 1. So let's check p by replacing 1 in the original equation. My solution set then is going to just be 1. So 1 equals 1 is a true solution. Next, I have this problem where I have multiple things happening. I want to stop and say, is there an easier way to get rid of the x's on both sides and put them on one side? And there is. If I look at this, if I add 2x to both sides, that is going to be the least amount of work because I have negative x plus 2x, which is just x. Now I'm going to subtract 10 from both sides in order to get x alone. And I get x equals negative 1. I'm going to check my solution by replacing negative 1 in the original equation, and I should get that it is true. So what do I do when I have more than two variables on different sides? I'm going to combine my like terms. And so what they did is they used different colors, but something I will do is circle all the r's in the problem. That way I can visually see the grouping. So colors don't always help me. I like to visualize it. So I can simplify 9 plus 4 is 13, and 9 plus 3 is 12. Now I have to make the decision, do I want to move 13 to the other side or do I want to move 12? If I subtract 12 from both sides, I'm going to get a positive r, so it's going to be easier. And then I'm going to have r plus 4 equals 4, subtract 4, because that's my inverse operation, from both sides, and I get 0. And in our last example, we have the distributive property. Remember, that means that everyone has to be multiplied by 4 in the first set, and then in the second, everyone has to be multiplied by negative 1. So when I complete that multiplication, this is what I wind up with. I'm going to simplify the multiplication, and then I'm going to work on combining like terms. I have 4x's minus 3, which is just 1, and then I have plus 4 minus 5, which would be minus 1. I want to get x alone, so I add 1 to both sides, and I get x equals 2. So even though this had two distributive properties, it wasn't that bad of a question. And that's the end of our addition properties.